Hey guys, so today we're going to be proving the hypothetical syllogism using logical derivations. Argument we've talked about in class before. It's one of those classic syllogisms that we already have proven valid by doing truth tables for it. In fact, it was on one of the homework assignments, right? So you should be able to do it by now in terms of truth tables, but let's look at an example anyways, just to remember what the argument's like. So here I have an example. If it rains and the streets are wet, if the streets are wet, then it is dangerous to drive fast. And if it rains, then it is dangerous to drive fast, right? That would be the conclusion, right? So you're kind of cutting out the middle, right? You're cutting out the middle B to go straight from A to C, right? So the conclusion is if A then C. Clearly what we're going to need to do is prove if A then C from if A then B and if B then C. What we need to do is we need to introduce a conditional. Right? We need to introduce a conditional. The conditional, obviously, that we're introducing is if A then C. Right? Which we don't have here. So how do we introduce a conditional? Well, we introduce a conditional by making an assumption. And an assumption is a special kind of premise. Basically, you can assume anything, right? But there's not a lot you can do with your assumption, okay? One of the things you can do with your assumption is to make a conditional, right? Why? Because if you look at a conditional, the structure of a conditional is already hypothetical, right? It's saying if A is the case, then B is the case, right? So one of the things we can do is we can assume A might not be true, A might be false, it might be true, okay? But we can assume it anyways, and then just see what would happen if A was the case, right? So let's start by doing that, okay? We add A as an assumption, right? We got this line here just to show where our assumption is taking us, right? And how far we go with it. So the first line is A, that's an assumption. Right? And what can I do with this assumption? Well, one thing I can do with it, pretty much the only thing of importance I can do with it, is to eliminate the first conditional, right? So we get B. We've eliminated this conditional in line 1 and line 3, right? Okay, if I have B, then what can I do? Well, I can go do the same for the next conditional, right? Get C. Another conditional elimination with 2 and 4. Okay. So now I go from A to B. Oh, sorry, from A to B to C, right? And I can use that to show, to introduce a conditional, okay? Because the course of this assumption basically sets a conditional, right? If I assume that A is the case, then I discover that C is the case, right? So as I said, one of the things I could do with an assumption is to introduce a conditional from it, right? So we have if A, then C, right? Lines 3 to 6, and the rule I'm using here is a conditional introduction, right? And this is our conclusion, okay? So this is how we use an assumption, right? Just some general rules of an assumption. First off, you have to close out an assumption before you move on to do other things, right? So if I make an assumption, right, that means I need to use whatever rule to complete it right before I move on. And once I've completed the assumption, I can't go back and change anything inside it. Right? I can't go back to the assumption. Likewise, other than the thing I derive from the assumption, I can't actually use anything from the assumption, right? So let's take this premise B. I don't know that B is actually true or false, right? The only reason I think B would be true is because I've assumed A. But A, of course, is an assumption. I don't know that A is actually the case. I'm just saying, well, let's just assume that A is the case, right? that means I can't say add as a premise B and C, okay, because that would be a violation of this rule, right? You could imagine basically what that would consist of is I could just say, well, this would be a proof that God exists. I could say, well, just assume that God exists, therefore God exists, right? Likewise, you could just say, as a proof that God doesn't exist, just assume that God doesn't exist, therefore God doesn't exist, right? So you can't use an assumption to prove anything other than certain things like a conditional, right? There are a couple of the things we can do with assumptions, but what we can and can't do with them is very limited, okay? And I'm going to pause this, and I'm going to show the next case of how we might want to use an assumption. This is the other way so far that we're learning that we can use an assumption. And this is a little different than the previous way, okay? This is the disjunction elimination rule, right? So it works with something like this. Okay, first I write if A then B, I write down the premises right like I always would. Technically speaking, we should really be using parentheses, but it doesn't really matter because these are just single connective arguments. For future reference, it is good to use parentheses, but putting that aside for now. So let's figure out what we're going to do here. Okay, so we want to prove B, right? And we can prove B by showing that A is the case or C is the case because both those things lead us to B, right? But here's the problem. We don't have A and we don't have C. We have A or C. And we can't plug A or C into A and C, right? Presumably we should be able to and get B. We know that B is going to be the case because either A or C is going to be the case, right? Let's say the argument is if I have apples, then I'll be full, right? If I have oranges, then I'll be full. And I'll have either apples or oranges, right? So no matter what we know, we're going to end up being full. The problem is we don't have the ability to prove that yet, right? So here with these tools, we're going to learn how to prove this argument, okay? And we're going to use assumptions again. So the way we're going to do assumptions is slightly different. This is going to be the disjunction elimination rule, right? And the problem with the disjunction is that there's two parts. So we have to make two assumptions in succession, right? And see what we end up with. So here, okay, let's say for our assumption might be A, right? So start with the assumption A. Okay, 5 would be B, okay, via a conditional elimination on lines 1 and 4, right? Now we can end this assumption, right? We make a new assumption of C. And we're going to end up with B again, also by a conditional elimination on lines 2 and 6, right? Now if you look, both of these assumptions lead us to B, right? And because of the disjunction on line 3, right, we know that one of these two assumptions is true. Okay, so no matter what, we know that B is the case, right? And we get this through disjunction elimination, right? And the disjunction in question is 3, right? And we have all these assumptions here, right, that help us get there. So this is basically how we use a disjunction elimination equation, right, to prove B by using these assumptions, okay? Okay, and there's a variant though. Let's switch this up a bit. Okay, instead of C, if C then B, let's say it's if C then J, right? And what we're actually trying to prove is B or J. Okay, the argument's going to look pretty similar. Okay, let's just erase it anyways and see what it looks like. Okay, now, again, we're going to assume A. Okay, and 2, we end up with B, just the same, right, with a conditional elimination on line 1 and 4. Okay, and that's our first assumption. The second assumption is going to be C. Any guesses where we go next? Well, it's going to be another conditional elimination to get J. Right, and that's going to be on lines 2 and 5, right? So, okay, now we have one of these assumptions leading to B and another assumption leading to J. That's pretty convenient because the answer we're looking for is B and J. So the conclusion of the disjunction elimination is actually B or J. Right? So here, right, we have two assumptions, right? But we're getting two different results from the assumptions. So now we get a new disjunction instead of a single letter. Basically, the rule for a disjunction elimination is always going to be you either end up with one value when both your assumptions lead to the same place. So that's when both, you know, if A then B and C then B, then we're going to both get B, right? Or we end up with a disjunction if the two arrive at a different place, right? And here they arrive at a different place. We get B and we get J, right? So this is basically how assumptions work, right? And here we have these two rules, the conditional introduction, where we use an assumption to derive a new thing, right? And we have the disjunction elimination, right? Where we use the disjunction to, we just assume either end of a disjunction and see what happens, right? And those are the two ways to learn assumptions we've learned so far. We will be learning more as the course progresses. Thank you.